Hi everyone, let's get started first by just doing a little review of what all we have learned so far. So far, we've been talking about proportional relationships, which always keep in mind means when one term is multiplied by a constant number or the same number to get the other term. So that's all that's happening. In this topic, it's kind of broken down into two main subdivisions or whatever you want to call them. And the first is how do we test if something is proportional? And we have three things that we're working with: tables, graphs, and equations. So if you're given a table, how do you test to see if it's proportional or not? Well, remember that's the one where we find our quotients and you see if they're the same. So find your quotients and see if they're the same. If they are the same, that's good news because that means it's proportional, because that means you've multiplied it by the same number. If they're not the same quotients, then it is not proportional. Next is testing a graph. Remember, for this one, it has to have two things in order to be a proportional relationship. The first is it has to be a straight line. So it can't be bent, it can't have any breaks in it, has to be straight. And then the second one is it has to hit the origin. So if you're given a graph, just check if it has those two characteristics, and if it does, you're good to go. With an equation, we kind of turn this definition into what would that look like for an equation. So one term multiplied by a constant number, k, times x, to get your other term. And k, in that case, is that constant number. Then we moved on to, okay, well, what if it is proportional? Then how do I find that constant of proportionality? And that constant of proportionality is that constant number that you multiplied it at the beginning. So remember, if you're given a table, to find the constant, you need to do y divided by x. And in this case, the order does matter. You have to do y divided by x. If you're given a graph, remember to go to the point where x equals 1, and then your y value is the constant. I'm going to write k for short, since that's what we use in an equation. And then in an equation, you see what k is. K is that constant. Don't overthink that one. It really is just as easy as it sounds. So for the rest of today, we're going to kind of talk about how do we take all that stuff that we just reviewed and combine it. So how do we write equations if we aren't first given the constant? Because so far with all the equations we've written, we've been given the constant at the beginning. And then lastly, we're going to keep working on going back and forth between graphs, tables, and equations. So before we get into the new stuff, let's look on the types of writing equation problems that we have been doing. So for these, always keep in mind that all proportional relationship equations will be in the form of y equals kx. So that's always like your end goal. Get your specific k and put it back into that form. So as two warm-ups, we have each movie ticket costs $6. Write an equation to represent the total cost of any number of tickets and define your variables. Don't be lazy. So I want to think, well, first, I am calculating the total cost of any number of tickets. Whatever you're calculating for, that's going to be your y. So my y is my total cost. So I want y equals something. Well, then think, how do I get my total cost? And by doing that, I take the price of one ticket, 6, and multiply it by the number of tickets. So I need a variable x, and x would represent the number of tickets that I purchased. And we're done. So let's look at the next one. The next one says each bag of pretzels contains 32 pretzels total. Write an equation to represent the total number of pretzels for multiple bags. Define your variables. So what am I trying to calculate? Well, I'm trying to find the total number of pretzels. So that's what's going to be my y. Number of pretzels. So I want y equals something, and then how do I find the total number of pretzels? Then I'm going to take the number in one bag, which is 32, and multiply it by my number of bags. So in this case, x would be the number of bags that you had. Pretty straightforward. So now we're going to get into what happens if they don't give you that constant right away in the problem like those last two had. So hopefully this table looks familiar because we talked about it when we were discussing how to find constants in a table. But just as a reminder, it says a charity fundraiser, the total money is calculated by how many tickets are sold. Write an equation that represents the total amount of money that the charity raises. So right now the main difference is I have a table of values instead of just directly given how much one ticket costs. So what we need to find first is the constant. And to do that, I can see, well, they raised $3,600 off of 160 tickets. So what I want to be thinking is how much money did they raise off of one ticket? So I'm going to do that 3,600 divided by 160. And that gives me 22.5 or $22.50. This now is going to become my K in the equation. So main goal here is to write an equation that represents the total amount of money the charity raises. So we're going to have y equals 22.5x, where y is what I'm calculating for, the total raised. And then if we think about where that comes from, it comes from how many tickets are sold and the price of one ticket. So $22.50 per ticket, so I need to multiply that by the total number of tickets. And that will finish up my equation. If I look at this next one, which again should be a familiar type of problem from when we first learned about the constants, I'm no longer given a table. I'm just given a couple of sentences. So let's read those together. The weight of a stack of books is calculated by multiplying the weight of a book by the total number of books. If a stack of 9 books weighs 15.75 pounds total, how can we write an equation to calculate the total weight of any number of books? So I'm not given a table, but I am given two values, and that's enough to find my constant. So I want to think, well, if 15.75 pounds is for 9 books, my constant would be how much does one book weigh? So I need to do 15.75 divided by 9, which gives me 1.75. So that's going to be my K. So when you're given a table, you really only use two of the values anyway. So in this type of problem, when you're just given two values, it's totally fine. Just use those to find your K first. Once you have that, you're ready for your equation. So if my goal is y equals kx, I'm now going to have for this problem y equals 1.75x, where my y is the total weight, and my x is the number of books that I had. Looks good. Let's move on to examples when you're given a graph instead of a table. Again, this graph is used from the earlier lesson about constants, and it says write an equation that shows the total number of wing beats in a given amount of time. So we have a male hummingbird wing beats over seconds and the number of times it beats per second. To find my constant, I need to go to where x equals 1. So I'm going to find that on my graph, which is right here, go up and see what y value is that, which in this case is 80. So my constant is 80, which means my equation is going to be y equals 80x, where y is the total number of wing beats, and my x, in this case, would be my number of seconds. So after watching this, you guys are going to try some of these on your own with a partner. So your substitute will pass out a packet of problems to work on. And again, you'll be using tables, maybe just two values or graphs to first get that constant and then write an equation from it. So a good practice of a little bit of everything that we've covered so far.